हरिः कर्ता।
So, as we have discussed in our story, Prasad is the owner of a grocery store and he wants to understand the relationships between items that customers frequently purchase together. One day, he heard about the a priori algorithm, a popular method for finding a meaningful association rules. So now he's decided to understand a priori algorithm in detail. So the a priori algorithm works based on the principle of if an item set is a frequent, if an item set is frequent, then all of its subsets must also be frequent. Must also be frequent. In simpler terms, if a particular combination of items is frequently bought together, then any subset of that combination is also likely to be frequently bought together. So a priori principle holds due to the following property of the support measure, which is x comma y two subsets, sorry, x comma y two item sets. If x comma y are part of a same data set, if x a subset of y tends to s of x, that support of x always greater than or equal to support of y. If x subset of y, then support of x greater than or equal to support of y. So support of an item set never exceeds the support of its subset. That's the main point of a priori principle. This is known as the anti-monotone property of the support. So a priori procedure, let's go step by step. Let's take it, it will be begin with k is equal to 1, then generate frequent item sets of length 1, that's the next step. Then third step, repeat until no new frequent items are identified. Then repeat length k plus 1, we have begun with k is equals to 1 na, then k plus 1, so two candidate item sets from length k frequent item sets. Then prune candidate item sets containing subsets of length k that are infrequent. Very, very important. Prune item sets containing subsets of length k that are infrequent. That's what we are going to do. Then finally count the support of each candidate by scanning the db, by scanning the gb. Okay, so and the last step under this is eliminate candidates that are infrequent, leaving only those that are frequent. So let's take a simple animation to understand this better. So let's illustrate a priori algorithm. So as usual, a priori principle is if an item set is frequent, then all of its subsets must also be frequent. So let's begin with a null subset, or sorry, null item set. And the first step is let's take k is equal to 1. K is equal to 1. From there, with using k is equals to 1, we are going to generate a frequent item sets of length 1. Let's generate length 1. So first item set A, second item set B, third item set C, and fourth item set D, and fifth item set E. So once it is done, now it's time to generate a two level item sets. Length 2. Now we have to generate item sets of length 2. So repeat until no new frequent item sets are identified using k plus 1. We have to use k plus 1. So 1 plus 1, 2. Now we have to generate a frequent item sets of length 2. So A and B. So I have to make the I have to make the combinations now. A, B, because A is not possible. So that is the reason. A, B, buying product AB is possible. Buying product AC is possible. Buying product AD is possible. Buying product AE is also possible. So that's what the combinations that we got. And similarly, buying a product BC, BD, BE is also possible. Next, buying product CD, CE, and buying product DE is also possible. So these are the respective item sets that we have here with a length of item sets of length 2. Okay, now let's go for the item set of length 3. So we can have A, B, C. So the item set should consist of A, B, A, C. So A, B, C, then A, B, D, A, B, E. So again, other uh, other item sets such as ACD, ACE, ADE, BCD, BCE, BDE, CD, and it will be repeated. So this is with a length of 3. Okay. Now it's time to make a length of 4. So it's buying a product of A, B, C, D together, buying product of A, B, C, E together, buying product of A, B, D, E together. So ABC and ABD are obviously subset of it, and BCD it works. Then ACD. So these four. And similarly for ABC, ABC, ABCE, ABC, then ABE, BCE, then ACE. And ABDE can be made up of another 3 level 4 item sets, which are ABE and ABD, ADE and BDE. Similarly for BCD, BCDE, BCE, BCD, BDE and CD. So the 4 item set consists of four 3 level 4 item sets with a length 3, and the final one is ABCDE, which consists of 5, which is an item set of 5 items, or item set of a length 5, and this is how. Okay, so our item set network has been created. Possible item set network has been created. Now it's time to eliminate, or it's time to prune the possible infrequent it's time to prune infrequent item sets. If you see AB in layer in layer 3 has doesn't have a frequent repetition, because it is only once AB. So that's the reason AB has to be removed. ABC also same. ABD, ABE also same. And ABCD, ABCE, ABCDE. So these are all found to be infrequent. These are all infrequent. These are not a frequent repetition. You see that AC you can find AD, whereas AB which is not no frequent, so it did not found to be frequent, so it is it found ABC, these are all found to be infrequent, so that is the reason these item sets were pruned. So this is how an a priori algorithm works.